This is Chapter 9, Gypsum Materials. Gypsum products are used mainly for positive reproductions or replicas of oral structures. Gypsum materials are used in dental offices and laboratories by dentists, hygienists, assistants, and lab technicians. Let's first discuss general considerations. And it's important for you to know that you need to know this whole slide, all the information in this slide. When we talk about a study model is a replica that is used to plan treatment and to observe treatment. The gypsum product that is usually used for study models is model plaster. When we discuss casts, a cast is a working model. It's used to fabricate an appliance or a restoration. It's either a replica of a quadrant or of a full arch. And the gypsum product that is normally used for a cast is dental stone. When we talk about dies, a die is a working replica of a single tooth. It's a removable part of a cast, and the gypsum product that is normally used for a die is high-strength dental stone. So let's take a look at page 128 in your book. There are some great examples here in your book. If you look at figure 9.2, let's start off with the picture identified by letter A. Here we have an example of orthodontic study models. As you look at the picture identified by letter B, here we have an example of dental casts that are made out of stone for partial denture construction. And then go to page 129, figure 9.3. Here we have an example of a cast with mounted dies. Take a look at the picture labeled letter A. Here we see 5 dies in a cast, and we can see that the teeth are identified by their tooth numbers. We have 6, 7, 8, 9, and 10. As we look at the picture labeled letter B, here we have an example of 1 die that's been removed. And then in the picture labeled letter C, we can see that all the dies are removed. So once more, the information on this slide is important for you to know. Here we have an example of impressions for study models, and the product that was used to create these impressions was the alginate impression material. Now this is an example of a study model, and another example of a study model. Here we see the maxillary arch, and here we see the mandibular arch. Let's now discuss the desirable properties for gypsum products. We're looking for accuracy, dimensional stability, ability to reproduce fine detail, strength and resistance to abrasion, compatibility with the impression material, color, ease of use, and cost-effective, and biological safety. Now let's discuss the physical form of the gypsum products. Gypsum products are made from gypsum rock, which is a mineral found in various parts of the world. Gypsum rock is mined, ground into a fine powder, and then processed by heating to form a variety of products. Chemically, gypsum rock is calcium sulfate dihydrate. Now, there are 3 types of gypsum products. They are plaster, stone, and high strength, or it's also called improved stone. And chemically, all 3 are calcium sulfate hemihydrate. They are all produced as a result of heating the gypsum and driving off part of the water of the crystallization. And this process is called calcination. Now let's go back to the information here on your slide. When we talk about type 2 gypsum products, we're actually talking about plaster. And plaster, or type 2 gypsum, is made up of beta hemihydrate particles. They are porous and also have an irregular shape. When we talk about type 3 gypsum products, we're actually talking about stone. And these type of products are made up of alpha hemihydrate particles, and they are less porous and have a more uniform shape. Now, when we discuss type 4 gypsum products, we're talking about high strength stone or dye stone. And these products are made up of modified alpha hemihydrate particles, and they are the least porous, and they are the most uniform in shape. And this entire slide is important for you to know. So here's an example of gypsum in rock form. And this is an example of dental stone type 3. So this is in powder form. Now let's discuss the setting reaction. When any of the three types of calcium sulfate hemihydrate is mixed with water, the hemihydrate is changed back to dihydrate by the process of hydration. The calcium sulfate hemihydrate dissolves in the mixing water to form the dihydrate, which is less soluble than the hemihydrate. The calcium sulfate dihydrate precipitates out of solution as interlocking crystals, which form a hard mass. Now, the chemical reaction with the gypsum stone occurs when 100 grams of powder is mixed with at least 19 milliliters of water. And that's very important for you to know. And the reaction is affected by temperature, chemical accelerators and retarders, and also spatulation. Now let's discuss excess water. Excess water is additional water that is used to wet and mix the powder, and this does not react chemically. The amount of the water, or the excess water, depends on the size, shape, and porosity of the hemihydrate particles, and that's important for you to know. So in regards to plaster actually requires the most water. So we may be adding some extra water to the mix, which will range from 18 to 31 milliliters of water. In regards to the stone, we may add 9 to 13 milliliters of water. And in regards to the high strength, we might add about 4 milliliters of water. Now let's discuss the setting times. When we talk about the working or the initial setting time, we're talking about the length of time from the start of the mix, when you start mixing the product with the water, until the setting mass reaches semi-hard. And this is actually detected by loss of gloss. You will see a loss of gloss. Now when we're talking about the final setting time, this is when the setting mass is rigid, which means hard, and it can be separated from the impression. All of the information on this slide is important for you to know. So now let's discuss variation in setting times. The setting time of a gypsum product is controlled by the manufacturer's particular formulation. Several gypsum products are available with varying setting characteristics. Either a fast setting or a slow setting product can be purchased. Sometimes it may be necessary to modify the setting time of a gypsum product in the dental office. Increased and decreased setting times may be obtained in the following ways. So, if you're trying to increase your setting time, by doing so, it will result in a slower setting product. And you're able to do this by decreasing the mix adding more water to the water and powder ratio, which creates a thinner mix. And you can also add certain chemicals called retarders. A commonly used retarder is borax. Now, if you're wanting to decrease the setting time, which then results in a faster setting product, the way to obtain this is by increasing the mixing. So the longer the mixing time, the shorter the setting time. You can also add less water in regards to the water to powder ratio. This will then create a thicker mix. And you could also add certain chemicals called accelerators. A commonly used accelerator is potassium sulfate. Other chemicals can also be used, but their effect on the setting time depends on the concentration and some other factors. Moisture contamination from improper storage can also change the setting characteristics. So everything on this slide is important for you to know. Now let's discuss setting expansion. All gypsum products expand externally during setting, and plaster is a gypsum product that expands the most. Minimal setting expansion is desirable for accurate dimensional reproduction. Increased setting expansion is caused by a thicker mix and increased spatulation and vice versa. Hygroscopic setting expansion refers to the increased expansion when gypsum materials are immersed in water during the setting process. Expansion could lead to distortion of the cast. Now let's discuss strength and surface hardness. Gypsum product must be able to withstand fracture or distortion during use. Strength is determined under terms of crushing or compressive strength. The higher the water to powder ratio, the weaker the product. For example, plaster. Now there are two types of strength. One is wet strength and the other is dry strength. Wet strength is the measured strength just after it sets. Dry strength is the strength that is measured when the excess water is not present in the sample. The greatest surface hardness occurs when the product reaches its dry strength, which many times is not realized under practical conditions. Casts and dies should be allowed to set for 1 to 2 hours, or preferably overnight or longer. In place of water may increase the hardness and improve the abrasion resistance. In regards to dimensional stability, the dimensions of a hardened or set gypsum cast are relatively constant under ordinary conditions of room temperature and humidity. However, gypsum is slightly soluble in water. Occasionally, it is necessary to soak a cast in water for a laboratory procedure. If the cast must be soaked in water, the water should be saturated with gypsum to prevent erosion of the surface. Now let's discuss manipulation. But before we do, let's look at page 134, figure 9.6. Here we have an example of equipment that is needed for the mixing of gypsum products. We have a scale, a rubber mixing bowl, a graduated cylinder, and a plaster spatula. So now let's discuss the water to powder ratio. Let's first talk about plaster. It takes about 45 to 50 milliliters of water to be mixed with 100 grams of plaster powder. In regards to the stone, it takes about 28 to 30 milliliters of water that needs to be mixed with 100 grams of stone powder. In regards to the high strength material, it requires about 19 to 24 milliliters of water to be mixed with 100 grams of the high strength powder. Now, it's important for you to know that By increasing the amount of water, it may result in a longer setting time, lower strength of the material, and also decreased expansion. Let's continue talking about the manipulation of the gypsum products. In regards to spatulation, water is dispensed first into the bowl, then powder is added and allowed to settle for 30 seconds. Then you begin mixing by hand for 1 minute. Often mixing is done mechanically with a vacuum mixing and investing machine. This provides a gypsum mix that is free of air bubbles and is homogeneous in consistency. If you go to page 134, figure 9.7, here you'll see an example of a vacuum mixing and investing machine. But in our dental materials lab, we will not be using a machine like this. We will be mixing by hand. Let's continue discussing manipulation. When we talk about accelerators, I did mention accelerators a little bit earlier. Accelerators are chemicals that increase the rate of reaction and reduce the setting time. Examples of accelerators are 2% solution potassium sulfate and calcium dihydrate crystals. So for example, slurry water is an accelerator, and you'll learn more about slurry water in lab. When we talk about retarders are chemicals that reduce the rate of reaction and increase setting time. Examples of retarders are 2% solution of borax, blood, saliva, agar, and alginate. And now our last slide. Our last bit of information in regards to manipulation. And this entire slide is important for you to know. The temperature of the water and the environment do affect the setting time of the gypsum. Now, when we're filling the impression, the gypsum mixture needs to flow slowly to prevent entrapment of air. The gypsum should flow ahead of itself. The dental vibrator is then used to bring air bubbles to the surface. So let's take a look at page 135, figure 9.8. Here we have an example of an impression that is sitting on a dental vibrator as it is poured with stone. We are now done with chapter 9, and as always, I encourage you to do the review questions at the end of the chapter.